Hi everybody. Now we are going to learn about the automatic battery charger using an SCR. I am Dr. V. Kritika. So this is the simple circuit by which we are going to charge a battery automatically. The components that we require to frame the circuit are a single phase AC supply and a single phase transformer, a bridge rectifier, a center tapped rectifier, and then SCR, resistors, Zener diode, a diode, and then a battery with a switch. This is the single phase AC supply. Though windings of the secondary seems to be large compared to the primary, it is only for the circuit purpose to make it neat. It has been drawn, but the understanding should be made such a way that it is a step down transformer. So primary will have more number of turns compared to the secondary. So it is a 230 volt 15 or 15 volt center tapped transformer with 2 amperes. And we have two diodes D1, D2. IN5408 is also mentioned here. This is to frame or to form a center tapped rectifier. Why do we need a rectifier? Because we have to charge a battery which is a DC supply, available as an AC supply. So we convert the AC supply that is available in the transformer to a DC at this node. And then we have SCR, diode, resistor here and here, then a Zener diode. So single phase AC supply is passed on to the transformer. It is stepped down from 230 volt to 15 volt with center being 0. So let us try to understand the rectifier part first. This circuit, this part is a center tap rectifier. How does a center tap rectifier work? We pass the current. Once the supply is given, the current passes through this diode, and we all know a diode works only when it is forward biased. So during the positive half cycle, D1 conducts. During the negative half cycle, D2 conducts. So during the positive half cycle, this is positive and this is negative. And during negative half cycle, this is positive and this is negative. That is why D1 is conducting during positive half cycle and D2 conducts for the negative half cycle. So current flows from this way through D1, then through the load, and then return back to 0 center tap. Same way through D2 to this node, this way back to 0. So this is how it works. So we get at this B point, it is only the positive supply available, which is converted as DC from the AC supply. And this makes right now my SCR readily available to conduct. Likewise, and like a diode, the SCR will conduct only if the anode and cathode are forward biased, which means anode should be positive and cathode should be negative, and gate should have a sufficient potential, which should be a positive potential. So we have a positive potential here at the B node, which is nothing but the anode potential of the SCR. So it is forward biased, and we have to check how we are going to receive the gate potential. From this B point, the resistance will be connected along with the Zener diode, which provides a constant voltage to the gate. This is a positive potential. This node will have a positive potential, hence anode is also positive. Simultaneously, gate is also positive. So gate is also receiving a sufficient amount of potential now, which makes the SCR to conduct. So SCR is going to conduct and the gate is receiving a constant voltage because it's a Zener diode connected here as well as the resistor. So which means a fixed voltage, not a variable one, a fixed voltage is available across the gate, which means there is no variation of the supply in the gate, no change of firing angle. Now once the SCR is conducting, automatically the battery starts charging. Why? Because the positive potential is available across the positive terminal of the battery and the negative is connected to the negative end. So obviously it is connected, and now the battery starts automatically charging. This is an understanding that the switch is closed. Now, here after the battery starts charging and reaches sufficient amount of potential, automatically the gate potential drops down. It's because the negative is being connected, and so automatically it is not going to receive, the positive is connected to the cathode, because gate potential is between G and K, gate and the cathode. So gate will not receive sufficient amount of potential, or the gate potential drops down, which reflects in turns the conduction of the SCR. As I said earlier, if and only if we have a sufficient gate potential, the SCR will conduct. And so once the battery is fully charged, the gate potential drops down, and obviously the battery will be disconnected. Why? Because SCR is off and the battery is disconnected from the entire circuit, which means battery is not getting charged now. So this is how we try to charge the battery and to disconnect the battery once it is fully charged. That is why we call this as an automatic battery charger using an SCR. Initially, when the battery is not charged, the battery potential terminal voltage will be less compared to the anode potential and or the potential at the B, and therefore the SCR will be conducting. Whereas when the battery is fully charged, the gate potential is dropping, and here this will be equivalent, and so the SCR is not conducting right now and it is disconnected because the switch is open. SCR acts as a switch and it is not conducting, which means it is open, the switch is open, and so the battery is disconnected from the circuit and the supply. Hence it is not charged once it is fully charged. This is how battery charging is done automatically using an SCR. You can even try with the components that you have and make the circuit and make it work. Thank you.